All right, algebra fans, we're back into translating expressions, and really we're trying to focus on interpreting these expressions as well. Really trying to figure out what they mean and how they help us answer a question. I'm going to do 7, 9, and 11. So you've only got two problems to try in this Ed puzzle. So please pay attention on the three that I do, so you are able to complete the problem successfully. What we're trying to do in 7 is just interpret the meaning of the expression. So let's read the problem first, and maybe we'll try and write the expression ourselves before we get there. Frank buys P pounds of oranges. So we have P represents pounds of oranges. We know that right now. It tells us that. But they were 2.29 per pound. Well, I see this key word here, per. And per normally means multiplication. We can write that as a couple different ways, either a cross, an X, or a dot. That normally means multiplication. And he bought the same number of pounds, so the same number, that's interesting, the same number of pounds of apples. So P actually represents the pounds of oranges and also the pounds of apples, but apples only cost $1.69 a pound. So again, I see per pound is multiplication. So I see I have $2.29 times the number of pounds of oranges and $1.69 times the number of pounds of apples. So the expression we're given and the expression we need to interpret is this one right here. And what does this expression mean? Sorry, my handwriting got a little sloppy there. What does this expression mean? Well, let's break it into parts to try and understand that. What would this part express? Well, 2.29 per pound of oranges. Okay, so if I say that I bought 1 pound of oranges, I would pay $2.29 for 1 pound of oranges. But I didn't just buy 1 pound of oranges, I actually bought P pounds of oranges. So this 2.29 times P actually tells me the money I spent on oranges. So dollars on oranges. Well, if this is the money on oranges, that might give us a little hint on this. And maybe you're already screaming into your computer screen nice and loud, so your parents are yelling at you, that this is now the money we spend on apples. And we can think about it the same way. I pay $1.69 each pound, and I buy P pounds. So I can just multiply those together. But now if I have money on oranges and money on apples, well, we're at the store, so this expression clearly represents the cost of P pounds because I'm buying P pounds of what, though? Of both apples and oranges. Of apples and oranges. Okay, so give me your best shot at explaining this expression in number 8 on this Ed puzzle. We're going to shift gears and try to write some expressions now. And we need to kind of understand the situation. Eliza, our friend Eliza here, earns $400 each week. She gets that no matter what. Every week, she earns $400. Here's a keyword that's plus $15 for each new customer she signs up. Okay, so for a new customer, let C represent the number of new customers. Okay, so C represents the number of new customers, and we need to write an expression for how much she earns. Well, if she just shows up to work, apparently this is a pretty nice gig. If she shows up, she gets $400 each week. So this week she earned $400. Well, let's say that she also signed up a new customer. Well, she would add 15 to that. But she doesn't get $15 no matter how many customers she signs up. She gets $15 each time she signs up somebody new. And C is the number of new customers. So if I want to figure out how much she got paid for just the customers, I would take the number of new customers she signs up and have to multiply that by 15. But if I want to find her total, again, total would be addition, so I'm going to add them together after I multiply 15 by C, which is the number of customers. And that would tell me if she got one new customer, she would make $415. And if she got two new customers, she would make $430. Or three new customers would $445. And so on and so forth. So we would be going up by 15 for each new customer that Eliza signs up. I'll do number 11 and leave this focused on number 10 so you can give that a shot. A man's age today, all right, so we have a man's age today is 3 less than 4 times the age of his oldest daughter. Let A represent the daughter's age. Write an expression for the man's age. Okay, so let's try and make this an equation even here. Let's say that the man's age is M. I want to try to express M. Well, I can say that the man's age is equal to 3 years less than 4 times the age of A. So let's see if we can write that out in symbols now. 3 less than. Well, 3 less than to me means minus 3. I want 3 less than. So I'm going to subtract 3 from something. And what am I subtracting it from? Well, it's less than 4 times. 4 times, that's pretty clear. The age of his oldest daughter. And what was the age of his oldest daughter? Well, the age of his oldest daughter was represented by A. So in this case, we actually wrote an equation, but the expression that the question was asking for was 4A minus 3. Take a look at number 10 and give it your best shot. Good luck.